Hello there. Last year we looked at the three ways that two lines could interact in the coordinate field, and we're going to do that again, but this time with lines that are written in standard form. Standard form, if you remember, is something of the format where x and y are both on the same side, and it's set equal to a constant. We're going to have two such lines, and we want to know how they interact, and what that relationship between the A, the D, the B, the E, the C, and the F have to be, such that we'll get our different solutions and types of solutions. So the first one is infinitely many solutions. We're going to do this as the example up here. So how can I turn this? How can I find another line such that with this line I have infinitely many solutions? I could scale the whole thing by 2, that this is the exact same line, has infinitely many solutions. I could take half of the original, or a fourth of the previous one, still the same line, infinitely many solutions. You can also multiply by a negative. All of these have infinitely many solutions. The key thing here is what's happening to get from A to D, B to E, and C to F. And you have to apply a scalar to all of them. So whatever you multiplied to get from A to D, you multiply the same thing to get from B to E, C to F, so all of those ratios have to be the same. Now, if you have 0 solutions, you're actually in a situation with parallel lines. For parallel lines, you're going to need the same slope between x and y, but something different on the end. So we can double the original again. The key thing is that we are not going to double this last one over here. It's not important that it's 10 like it was up here. It could be 2 or 5 or negative 20, anything but 20, because if it's 20, it's the exact same line. Divide the original by 2 and do something crazy to the number at the end. Once again, the important thing, if I'm going to divide by negative 5, I do that to the x and the y, same scalar, and something different at the end so that they are parallel. So same scalar between the x's as the y's, that's the same, but this one is going to be different at the end there. Last one is to get exactly one solution, so infinitely many, it's the same line. 0 solutions, they're parallel. Exactly one solution, they have to intersect somewhere, and for that to happen, you need to have different slopes. So you need a different scalar between x and y. So here I took half of the first one, doubled the second one. It's going to wind up with a different slope, and it actually doesn't matter what you do to the last. You can also be more subtle and just change a negative to a positive. That will affect the slope just as well. So let's summarize this one. You need a different scalar between x and y. And as long as these ratios, so from here to here, here to here, you're using a different scalar, it actually doesn't matter what you use at the end there. So let's just recap. In order to have infinitely many solutions, you need to have a scaled up version of the entire line, and that means that you are the same line. If you scaled up the x and y's but did not use the same scalar on the constant at the end, you are going to have 0 solutions and be parallel lines. And if between x and y you have a different ratio, that means that your lines have different slopes, so they will intersect exactly once. Thank you for watching. Character and Scholarship for Life.